Good morning. Welcome to chapter 8, where we're going to be looking at geometry. So we're going to start in this video looking at lines and angles. Then we're going to be moving on into different polygons or shapes, looking at perimeter and area, then into circles and composite figures. We're going to take a look at triangles and some very special properties of triangles that allow us to calculate some side lengths. So we're going to look at that in the Pythagorean theorem. And we're going to finish off this chapter looking at 3D shapes in solid geometry. So a bit of vocab to get started. So geometry, well, what does that mean? Well, geo means earth. So this is earth measures of the earth. A point is just like you would say, I guess, in regular language, if you had a point on a piece of paper, it's like a dot. It's a location. We put a dot there, but really it has no size and it covers no area. Okay, a line is going to be a number of points put together. It has arrowheads on each end. So if you see here, down here, we've got a line. That means it goes on forever. So we have two arrows. And you can imagine this line going on forever to either end of this page and beyond. A ray has one line. So this is a ray here. We have a point on one side, like an end point, and then we've got an arrow on the other. So it's going off to the right forever. And a line segment is a chunk of a line that has two endpoints. So no arrows on that. Okay. There can be a few different types of lines we can talk about. Perpendicular lines are lines that are at 90 degrees to one another. So what that means is imagine a normal four-way stop, maybe not a Nelson one, but one on flatland in Alberta somewhere. Okay, so if you've got a normal four-way stop, you have equal distance between each of your kind of roads. These are all what we would call right angles at 90 degrees. We'll talk more about that later. But it's basically like, it's like a T, right? So we have four perfect corners in there. Parallel lines are two lines that never intersect. So imagine railway tracks that go on forever and ever. So here, remember, our arrows mean those lines go on forever and ever. They have the same slope in this case, which means they're never going to cross paths. So they never intersect. An angle is going to be two line segments, okay, or I suppose two rays that are going to share a common endpoint. So this is our angle here. We would call that angle Q. And Q has a special word. That endpoint is called the vertex. If we want to name an angle, there's actually a few ways we can do it. So take a look at this angle here. We've got ABC. So we could call this angle ABC. We could also just call it angle B, so just from the vertex, or we could call it angle CBA. All of those would be ways to name this angle enclosed by these two rays. Okay. Let's move on to talking more about angles. So when we're talking about angles, we often do use a protractor to measure angles. You will need a protractor for the section for your test. We do have a few available at the school if you need to borrow one, or if you have one, it'd be great if you could bring it into class. So we can have different classes of angles. The first one is acute. Let's start first at right angles. So right angles, those are the ones I was talking about before when we looked at perpendicular lines. They measure 90 degrees. So this right here is a right angle. And so it's like a perfect corner formed by two perpendicular lines or segments. An acute angle is going to be one that is smaller than that 90-degree angle. So if I drew an angle like this, that would be considered, this angle in here is acute. So we can think of it as a cute little angle. It's a cute little angle that's less than 90 degrees. An obtuse angle, on the other hand, is bigger than 90 degrees. So if I drew something like this, it's sort of like a fat angle, right? It's more than 90 degrees. So this would be obtuse. Okay. A straight angle is really just a line. Imagine you drew an angle. Here's my vertex, I suppose. That just goes on forever. So there is an angle in here. You could measure it with a protractor. It's going to be 180 degrees, which represents a straight line. So a straight angle is really just representing a straight line. So here we've got some examples of acute angles, all less than 90 degrees. And then you've got some obtuse angles here. That middle one is must be just a little bit greater than 90 degrees. And that third one there is almost a straight angle. It's almost 180 degrees or a straight line. If you weren't sure, for instance, if that middle one was obtuse, you would want to use a protractor, which we will use later. Okay, there are a few different types of properties we can talk about when we're talking about angles. Complementary angles are going to be angles that add up to make a 90-degree corner or a 90-degree angle. So if you look at the outside edge here at this line segment here and this one here, you might notice they form a right angle. I'll draw it really big here to show that's a right angle. That's at 90 degrees. And so that means those two inner angles there, that angle X and the 75 degrees, add up to 90. And so we can use that property if we wanted to figure out the measure of angle X there, because we know angle X must be the full 90 degrees minus the 75 degrees that's taken up by the larger angle on top. And so we can solve and get an angle of 15 degrees. Those two angles together would be called complementary. And the way I try to remember that is I think it is right to give a compliment. It is right to give a compliment. So you can imagine right means complementary. The other complement. The other kind of angles we can talk about are supplementary. And so supplementary angles are going to be angles that add up to make a straight line or 180 degrees. So if you look at this example here, we have angle X here, and then we've got this other angle, which happens to be 130 degrees. We know those two angles add up to a straight line. So they add up to 180 degrees. And so that means if we were trying to solve for angle X, we would say, well, it must be 180 degrees minus the 130 degrees taken up by that bigger angle there. And so we would get an X of 50 degrees. So we can solve for supplementary angles like that. Another type of angle is called a vertical angle. And I like to think of these as X angles because you can draw an X like you see here in this picture. And the angles that are kind of opposite each other, so this Y and this Z must be equal to each other. They're vertical to each other. That means they are equal. And to show they're equal, I'm just going to draw a line here and a line here. So that's showing those two angles are equal. Also, this other direction, I've got two X angles that are opposite to one another. So those two angles are equal. So to show that those are equal, I'm just going to draw two lines to show those two are identical to each other. So those are vertical or X angles. So if we were asked here to find the angle measurements, well, we're told angle W equals 59 degrees. So if we're told that, we know because they're X angles or vertical angles, that angle X must also be 59 degrees. So those two we've done now. What about Y and Z? Well, we can think of this a few ways, but let's think of angle X and Y as together forming a straight line. So together they're forming a straight line. In other words, they're supplementary to each other. And so that means that angle Y must be 180 degrees minus 59 degrees. And so what does that give us? So that gives us 121 degrees. You can use similar logic to find angle Z, or you can say, well, I found angle Y was 121 degrees, and it's vertical to angle Z, so therefore angle Z is also 121 degrees. Okay. Okay, another thing we'll often see in this section is a couple parallel lines like we have down below here. Often these will be, they're kind of denoted by these arrows. So if you ever see these arrows, that means that's indicating those two lines are parallel. And then often they're intersected by a third line and it creates a bunch of angles. So this is called a transversal, this line that intersects the parallel lines, transversal. Okay, and we have some properties that happen with transversal lines as well. And so we've got alternate interior angles, which I think of as Z angles because they kind of make a Z. I guess not the Z with the cross in it like I like to do, Z angles. Okay, so for example, if you look here at angle X and Y, you can imagine you could draw yourself a Z right here. Okay, with the two parallel lines being kind of the upper and bottom line of that Z. That means the two lines that are kind of inside the Z, so here that would be the X and the Y, are going to be equal to each other. They're going to have the same angle. Okay, so that's alternate interior or Z angles. Corresponding angles, I like to think of as Fs. These are F angles. And so if you think of an F, okay, you can think of, here's my F. That means that these two angles that are kind of underneath the lines of the F are equal. Or you could think of it, I suppose, as these two angles here are equal. I guess I could denote that in a better way. There we go. So those two are also equal. So for example, here, I'm going to draw myself an upside down F in this case. Okay, so here's my upside down F, and that's indicating that these two angles kind of made by that F, A and B, are going to be equal. They're corresponding angles. So often what you'll get is these kind of little puzzles here where they've given you one angle and they want you to find all the others. So there are always many ways to do these, but let's try starting with angle 1. So if we were trying to find angle 1, what property is going to help us figure that out? Well, I'm going to think of that as supplementary to angle 40. Okay, because I know that those two angles form a line, which means they add up to 180 degrees. So angle 1 then must be 180 degrees minus 40 degrees, which is 140 degrees. And 140 degrees. And sometimes you'll be asked to list the reason why. So it's always good to kind of get used to writing this with vocab. So we're going to say that's because it's supplementary to 40 degrees. To the 40-degree angle, supplementary to 40 degrees. Okay, so we've got that one now. Let's think about angle 3 next. Well, once again, there's a few ways we could think of this. We could think of this as supplementary to the 40 degrees as well, or you can think of this as vertical or an X angle to the 1. So let's say, so we know angle 3 must equal angle 1, so it must equal 140 degrees. And I'm going to say that's because it's vertical to angle 1. Okay, how about angle 4? Well, once again, you could argue this with supplementary angles, or I'm going to argue it that it's 40 degrees because it is vertical to that 40-degree angle. Okay, angle 5. Well, angle 5, you can imagine, forms an upside down F with angle 1. So that means it's equal to angle 1, which was 140 degrees. And that is because it's F angle or corresponding angle to angle 1. So corresponding to angle 1. Angle 6. Well, again, well, we could use 5. Let's use 5. 5 is 140 degrees. So 6 must be supplementary to that, which means it must be 40 degrees. If you said it was corresponding to that 40-degree angle, you would also be correct here. Or you could also say it's an alternate interior angle to angle 4. So like I said, there's many ways to do these. So I'm going to say it's 40 degrees because it's supplementary to angle 5. Okay, angle 7. Well, the first thing I see is it's vertical. So I'm going to say it's vertical to angle 5, which means it equals angle 5 at 140 degrees. So vertical to angle 5. And last one there, angle 8 is supplementary to angle 7. So that means it must be 40 degrees. So like I said, if you came up with different reasoning for these angles, that is perfectly fine. There's many ways to do these. But those should be the angles you get. So what I would say is, why don't you pause this video and see if you can do that next transversal and figure out those angles. All right, hopefully you had a chance to try this next one. Let's do it together. So angle 2 is supplementary to that 70 degrees, which means it's going to be 180 degrees minus 70 degrees. So we're going to get 110 degrees. And I'm going to say that's supplementary to 70-degree angle. Okay, angle 3 is vertical to angle 2, which means it must be the same angle. So it's 110 degrees vertical to angle 2. It's also supplementary to that 70 degrees. Vertical to angle 2. Okay, angle 4 is vertical to the 70-degree angle. So it must be 70 degrees. Angle 5. So that forms an F with the 70-degree angle. So it means it's corresponding, which means it's equal. So it's 70 degrees, and I'll say corresponding to 70-degree angle. Okay, angle 6 is supplementary to angle 5, which means it must add up to 180 degrees. So it's 110 degrees. Supplementary to angle 5. Angle 7 is vertical to angle 6. So it must be the same, which means it's 110 degrees. Vertical to angle 6. Okay, and last one, angle 8. And angle 8 is vertical to angle 5, which means it is 70 degrees. So I find these to be quite a lot of fun. They're sort of fun little puzzles, I think. And I hope you enjoy this section as well.